right, so to divide complex numbers, the way we deal with this is we multiply by the denominator's conjugate. And the reason why we do that is because we're trying to get rid of the imaginary number that is in the denominator. And when you multiply by the conjugate, something very, very, very special happens. So just off to the side here, if I have 4 minus 7i, and I multiply that by the conjugate. So the conjugate, we change the imaginary part sign. So we have negative 7i, we'll change that to a positive 7i. Now, because we have 2 terms times 2 terms, we need to FOIL it out. And you'll notice that when you FOIL here, the 4 times the 4 gives us 16. The outer is going to give us a positive 28i. Inner gives us a negative 28i. And then the last 2 terms are going to give us a negative 49i squared. Now, this is always going to happen when we have a conjugate times a conjugate. You're going to see that the outer and the inner cancel. So what will happen here when I multiply this fraction by the conjugate, and it's the conjugate of the denominator, so I change the negative to a positive 7i over a positive 4 plus 7i. Now, anytime we divide by a complex number, what will happen is we multiply by the conjugate. We're going to have to FOIL out the whole numerator, but as we just talked about over here, because this conjugate times the conjugate, the outer and the inner cancel, it becomes a Florida step. It's just the first 2 and the last 2. So when you multiply by the conjugate here, you will have to FOIL out that whole numerator. But in the denominator, you can save yourself some time and effort by just doing the first 2 and the last 2. All right, so from start to finish here, we started with a division of 2 complex numbers. Our first step was to multiply by the conjugate of the denominator. So we changed this minus to a plus, and then now we are left with in the numerator a problem that we're going to have to FOIL out. And in the denominator, we are left with a conjugate times a conjugate, which will just be a first and a last. All right, so let's do that now. So we take the first 2 here, so we get 24. The outer is going to give us a plus 42i. Inner gives us a plus 8i. And then the last 2 will give us a plus 14i squared, because we have an I times an I. Now, in the denominator, we're efficient about this. We say, okay, we're going to have the first 2, which is 16. The outer and the inner will cancel. And then the last 2 will give us a negative 49i squared. Now, at that point, we just have to simplify, combine our like terms. So we have 24 plus the 42i and the 8i are like terms. So that gives us 50i. And then remember how we said that this I squared changes the sign that is in front of it. So currently we have a plus 14i squared. So that is going to become a minus 14 when we change the sign by getting rid of the I squared. Now, in the denominator, we have 16, and the same situation happens in the denominator with this I squared. This I squared is going to change the sign and make it a positive 49 when we get rid of the I squared. And again, that is because I squared is equal to negative 1. And then from there, we just combine our like terms, so we end up with 10 plus 50i over 65. And we do need to reduce that, of course. So this becomes 10 over 65 plus 50i over 65. The 10 and 65, you can take out a 2, or a 5, to be left with 2 over 13. And then the 50 over 65, you can also take out a 5 and be left with 10 over 13i. And so that is our final answer. I do want to just mention with all of these I problems, it's important to know on your calculator, you can hit the second period button at the very bottom of the calculator. There's a little I in yellow right above that period button, and that will allow you to use your calculator to compute a division or a quotient of 2 complex numbers. But when you put this on your calculator, be super duper careful, because you do need parentheses around all of the numerator, and you need parentheses, that was not the numerator. You need parentheses around the whole numerator, 6 plus 2i, then divide it by parentheses, the whole denominator, 4 minus 7i. And then as we discussed in class, you can hit the math frac button, and that will give you the fraction form of the decimal approximation that your calculator spits out when you put this in as just an imaginary number.